let's have a look at question 4. So this is clearly a moments question. Let's have a look. A uniform rod AB has mass m and the length 2a. So if it's uniform, that means the center of mass should be right in the middle. So let's label this one as mg. And then a particle of mass 2m is attached to the rod at point C, where A is 1.5a. So 2mg should act at point C. And then the rod rests with its end A on a rough horizontal ground. So as long as they have contact, that will be a normal reaction. So we call it RA. And because it's a rough horizontal ground, so that will be some friction. And then the rod is held in equilibrium at an angle theta to the ground by a light string that is attached to the end B of the rod. So then that will be a tension here, so that's called T. And then the string is perpendicular to the rod as shown in figure 2. Explain why the frictional force acting on the rod at a x horizontally to the right on the diagram. So because it's in equilibrium. So if it's in equilibrium, that means the force in any direction should be like balanced. So basically up equal to down, left equal to right. So if you look at the horizontal direction, so because the friction is like has to go this direction. So if you look at the horizontal direction, RA, mg, 2mg, they are in the vertical direction. You can't really do anything, yeah. So, but tension is not. So if you resolve it, you will see one component you can resolve in the perpendicular direction, another one you can resolve in the horizontal direction. So because the horizontal component of the tension is to the left-hand side, so that means the friction has to be to the right-hand side to make it equilibrium. Otherwise, it won't be equilibrium anymore. Yeah. So to write this down, you just say, since the horizontal component of T is to the left, then the frictional force has to the right to make it equilibrium. And that's all we have to say. And then part B. So the tension in the string is T. Show that T is equal to 2mg cos theta. So let's just ignore those two components first. We just look at the force we already have in here. So we want to show T is equal to 2mg cos theta. So like always, we took moments at point A. So we can ignore RA and then FA because they are on the same line of point A. So we only need to care about mg, 2mg, and tension. So to set this up, we just let the force clockwise equal to the moments anti-clockwise. So mg, 2mg are in the clockwise direction. So we do that first. So that would be mg times by the shorter distance. So moments is equal to the force times by the shorter distance. So this is the shorter distance. And then we know the length of the rod is 2a since it's uniform. So this is right in the middle. This has to be a. So we can just do mg times by a cos theta because this length is adjacent. And then plus 2mg times by its shorter distance. So again, from point A to 2mg, this will be the shorter distance. We already know AC is 1.5a. So if this length is 1.5a, and then this, what we're looking for is the the adjacent. So it has to be 1.5a cos theta. And then that's equal to tension times by the shorter distance. So the shorter distance from point A to tension is just this length because they are perpendicular. Shorter distance is a perpendicular distance. So then we know AB has length 2a, so just times by 2a. And all we have to do is just simplify this. So we can divide by a for both sides. And then that would be mg cos theta plus 2 times 1.53. That would be 3 mg cos theta. And that's equal to 2t. And then add them, that would be 4 mg cos theta is equal to 2t. So therefore, tangent is just equal to 2 mg cos theta. And that's what we want to show here. And then given that cos theta is equal to 3/5, so we can draw a little triangle as before. So theta, right angle triangle, adjacent is 3, hypotenuse is 5, so the opposite has to be 4. Then we know sine theta is 4/5, and then tan theta is 4/3. And then show that the magnitude of the vertical force exerted by the ground on the rod at A is 57 mg/25. So that means RA. They want us to show that RA is equal to 57 mg/25. So now we already know what tangent is. So substitute in. So tangent equal to 2 mg cos theta, and the cos theta is 3/5. Then we can write this as 6/5 mg. And then we just let the force goes up equal to force goes down and left equal to right. So now we use the vertical and the horizontal component. So the vertical component has to be, because this is theta, so that would be t cos theta, because that's adjacent. And then this one clearly is the opposite. That would be t sin theta. So up equal to down. So up would be RA and also t cos theta. And then down would be mg and then 2 mg. So simplify that. RA is just equal to, so add them together, that would be 3 mg. And we minus t cos theta. So tangent is 6/5 mg. We already worked it out. And then cos theta is 3/5. So what do we need to do here? Just do 3 mg. So just do 3 minus 6/5 times by 3/5 mg. So 3 minus 6/5 times 3/5, that's just 57/25. So that's just 57/25 mg. That's what we need. And then for part D, the coefficient of friction between the rod and the ground is mu. And then given that the rod is in limiting equilibrium, so if it's in limiting equilibrium, the friction is equal to mu r. And then it's at point A, so it has to be mu RA. So friction is equal to, so friction is to the right-hand side. That will be equal to the force to the left-hand side. So that's equal to T sin theta. And then we know everything we need. So RA is equal to 57/25 mg. We already know. And then tangent is 6/5 mg, which we already worked out from before. And then sin theta is 4/5. So divide by mg for both sides. And then mu times by 57/25 is equal to 24/25. So divide by 25 for both sides. Or, I mean, times by 25 for both sides. Then we can cancel out 25 in the denominator. Then mu is just equal to 24/57. So simplify that, divide by 3 for both top and bottom. 24 divided by 3, that's 8. 57 divided by 3 is 19, which is what we need.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.